My name is Karina Schoengold. I'm a faculty member in the Department of Agricultural Economics here at UNL. I'm a resource economist, and my research is focused primarily on a range of issues related to agricultural production and environmental management, environmental policies, resource use, and associated policies. This project started as a collaboration and discussions and brainstorming between some faculty members in South Dakota, Kansas State, and here. We wanted to develop an idea that built on the strengths of the region as well as the strengths of the researchers. And one thing that we realized is that there are challenges with the growing use of plastics in agriculture and associated pollution, and we thought that this could be an opportunity to create something new that was both beneficial from an environmental standpoint, but also from an economic standpoint of creating opportunities for rural communities in the region. The bioplastic technology that we're trying to develop and we're developing in this project is to create bio-based material that can be used on crop fields, and the material will biodegrade into the soil and will be beneficial for soil properties and crop growth. So this is distinct from another type of bioplastics that many may have heard of that's been used for more packaging, so more consumer-oriented products. If you go to the grocery store, maybe your packaged lettuce is in a bioplastic container which has been derived from biomaterials and it can be composted and is biodegradable. That is a different type of bioplastic that's also important, but that's distinct from what we're working on in this project, which is really focused on developing bioplastics for the crop production cycle. There's been limited use of bioplastics in the agricultural production side of the process. It's still been mostly in experimental state. There's been work being done in this area for 10 or 15 years, but much of it is not actually feasible for commercial use yet. Our goal is to develop something that's sprayable. The plastics that are currently used in agriculture are films that are sheets that are put onto crop fields, and we hypothesize that it would be more effective to adapt to different conditions if we have something that's sprayable, something that can use existing technology and doesn't have to get rolled out onto different fields. And so one challenge is to create something that is water soluble, that can be sprayed onto crop fields. To do this, there's several different sources of material that we're looking at. One of the things that one of my collaborators has suggested, which I'm really enthusiastic about, is the potential use of hemp protein. Given some of the changes in the Farm Bill to provide support for hemp production for industrial purposes, it's something that is a new market that's developing, and so if we can work with that new product in a way that can create something beneficial, I'm very excited about that as a possibility. I think that has a lot of potential. The second primary goal of our project is to measure the agricultural effectiveness of this technology. So once this technology is created, we want to see how does this perform in the lab and in the field. And to do that, we have collaborators who work with both greenhouse trials and on-field trials at some of our experiment stations. And so we have facilities to use materials that are developed and to test how they respond to different conditions. One of our goals is to measure the environmental effectiveness of this. With our team, we have researchers who are knowledgeable about how to model both water and soil impacts of using different technologies. And so once we have material that we can use on the field, We have techniques to measure things like runoff, sedimentation, erosion, water filtration, and any water quality impacts that would occur from using it. We can also measure things related to sequestration within the soil and a range of other environmental impacts from those field trials. The third significant goal of this project is to measure the economic and social impacts of this technology. And so we're really looking at this technology, the potential for it, holistically, from the beginning of can we create it to downstream, will producers use this technology? Will rural communities have the capacity to invest in facilities to create the technology? Will consumers be interested in paying a premium for products that are produced using this technology? And geographically across the region, are there differences that we can measure in terms of potential capacity? We have very large ambitions about this, that we would be able to help move agricultural production away from the use of plastics and towards a technology that reduces contamination to soil, reduces contamination to water, and also provides an economic opportunity for local production. I think that this is something that if, it's preliminary, but if it works, there's enormous potential, both on the economic development of the products as well as the use of it in the field. And so I think it's very exciting.